Welcome back. We're going to continue going through the standard quiz model from the 2019 AP Calculus AB Term 1 standard quiz. Today we're going to focus on, or in this video we're going to focus on the 10th question, which I think is actually the simplest of all the questions, which asks you to compute the average rate of change for a given function over a closed interval. So before we do anything else, it's worth reminding you that the average rate of change formula is the same all the way through. It's basically the slope expression that you used back in Algebra 1. So, does not want to stick around. There we go. So you might remember it as this, y2 minus y1 over x2 minus x1. But of course that for us, in the context of function notation, is going to be f of b minus f of a over b minus a. So it's just that expression. We're just going to find the 2 points and then calculate the difference quotient. That's all it takes. So for our particular example, we're talking about the function 3x squared plus 5 on the closed interval from 0 to 3. So in a sense, what we're trying to compute is f of 3 minus f of 0 over 3 minus 0. Now for our purposes, we can compute each of those values. Of course, our denominator is pretty clean. It's just 3. For f of 3, we have to plug in x equals 3. So we'll get 3 times 3 squared plus 5 minus 3 times 0 squared plus 5 as well. So there is our answer. We just are going to simplify it a little bit. That's going to give me as our values 3 times 9, which is 27, and 27 plus 5 is 32, minus 0 plus 5, which is 5, all over 3. This then gives us 27 over 3, which is then going to give us 9. So the average rate of change, or the average slope, or the slope of the secant line along this graph would have slope 9. For part B, nothing really different. It's the exact same setup, the exact same stuff. The only difference is, of course, the function. So it's an opportunity to see if we can check your algebraic and arithmetic skills. So in looking here, we've got the rational function 10 over x minus 2. So note that there is a vertical asymptote somewhere in the middle there on x equals 2, but that isn't even a part of our interval, so we don't have to even worry about any sort of weird issues there. And from there, we're on the closed interval from 4 to 12. So that means our average rate of change is going to be f of 12 minus f of 4. All divided by 12 minus 4. From here, if we plug in, we're going to get 10 over 12 minus 2, which is 10. And then minus 10 over 4 minus 2, which is 2. All over 8. Simplifying here, we get 1 minus 5 over 8. That's going to be negative 4 over 8. Of course, all of these are correct answers now that we're here on this side. But that does simplify to negative 1/2. So the secant line through along that closed interval to the graph of f of x, this rational function, would have slope negative 1/2. For part C, again, what else can we throw at you? We can throw at you a trig function. Make sure you can actually evaluate these trig functions and, of course, simplify a little bit if you can. So from here, same setup. We've got a sine curve. It's a negative sine curve. So if you're someone that likes to think about pictures here, we've got something that looks along like that. In fact, I believe our closed interval is the one right here. So we should be expecting a negative average rate of change, also known as a negative secant slope. So in going through here, we're going to have f of pi over 2 minus f of 0, all divided by pi over 2 minus 0. As a reminder, we've talked about before that you don't have to simplify. This is not a situation where you could accept that as your final answer, though. You do have to evaluate all functions. So in this case, we're going to have negative 4 sine of pi over 2. We'll evaluate this in a second. Minus a negative 4 sine of 0, all over pi over 2. So this is going to be a little bit crunchier than some of the other ones have. As far as sine of pi over 2 is 1, so we get negative 4 times 1, plus 4 times sine of 0 is 0, all over pi over 2, which means that our slope, our average rate of change, is going to be negative 4 over pi over 2, also known as negative 8 over pi. So there is our average rate of change on the interval from 0 to pi over 2. Finally, for the plus question, like again, what can we do? Usually it's algebraic. Here, maybe give you a more complicated function, something like that. In this case, they tell us that the average rate of change for this log function on the interval from negative 1 to b, so we're assuming b is larger than negative 1 as well, is going to be 2 over b plus 1, and they want us to find b. So at this point, I'm not sure exactly what it's going to ask us to do, even though I wrote the question. I'm just going to start to attempt to calculate the average rate of change and then see if we can solve the equation. So this is another kind of K question, solving kind of question. So in here, we're going to have f of b minus f of negative 1 all over b minus a negative 1. So for our purposes, the denominator is going to be b plus 1. That's interesting because notice there's a b plus 1 denominator over here. That might actually help us. As far as the values themselves, if we do f of b, that's going to be log base 3 of b plus 4. And then if we do f of negative 1, we're going to have log base 3 of negative 1 plus 4, which is just plain old 3. So simplifying as much as we can, we get log base 3 of b plus 4 minus log base 3 of 3, and the power of 3 that gives us 3 is 1, all over b plus 1. So there's our average rate of change. Of course, we need to solve for b. This looks complicated, but it does say up here that that average rate of change is 2 over b plus 1. So with that in mind, if we go to solve this equation, the b plus 1s will divide away. We can multiply both sides by b plus 1. Just assume that b isn't negative 1. We should be fine. And then from there we end up with the equation log base 3 of b plus 4 all minus 1 equals 2, which means that log base 3 of b plus 4 has to be equal to 3. If we rewrite this in exponential form, we'll get 3 to the third, also known as 27, has to be b plus 4, and that tells us that b is equal to 23. So that's the value of b necessary to create the average rate of change we were told to find. So with that said, that covers the 10th question, which was focused on the average rate of change. And as I said, this is probably the simplest and cleanest of the questions along the standard quiz or the standard quiz model.